Okay, Chapter 10, Quadratic Equations and Functions. 10.1, graph y equals ax squared plus c. This begins on page 628. We're graphing a quadratic equation, and how do you know this equation is quadratic? Yep, it's that exponent of 2. The input is being squared. So before we put our rule together for graphing quadratic equations, leave a space and we will go graph one so that we can kind of then come back and understand how the rule was put together. So let's graph an equation where a, this coefficient, is greater than 1. Okay, so in order to do that, let's go ahead and make a table, right? And then we'll plot the points and draw the curve. So we're going back to our most basic method of graphing, using a table. So you might need to pause. And let's try graphing y equals 2x squared. So 2 is a number greater than 1. So that's why we're trying this. Notice that we are asked to graph equations that have ax squared plus c. So what would we be adding to this? It would be plus 0, right? So this is a basic quadratic equation. Now, when we start plugging in values, we might just use a couple negatives, a couple positives, and 0, right? What happens when we plug in 0? 0 squared, 0 times 2 is 0. Good. And let's try our positives. Plug in 1. 1 squared is 1 times 2 is 2. Plug in 2. 2 squared is 4, and 4 times 2 is 8. Okay? Let's go to the negatives. Negative 1 squared. Negative 1 times negative 1 is 1. 1 times 2 is positive, isn't it? 2. Negative 2 squared is 4. 4 times 2 is 8. So in our range, we have no negatives. Interesting. Okay, so let's plot these. Let's start with the center 0, 0, right? And we'll go walk 1, fly 2, and walk 2, fly 8. This is a 10 up here, right? On this graph, every line represents 1 unit. Okay? Let's walk negative 1, and when we do, we fly 2. Walk negative 2 and fly 8. Okay, so now when we draw the curve, as we have seen before, let me see if I can do this. Not be curving back. It's what shape? It's a U-shaped, right? And so it is increasing a little bit as out the x as it's increasing steeply in the y, right? And it never will come back and meet itself. It's just getting ever so slightly greater in the x direction as it gets very high in the y direction. So we call this type of U-shape a parabola. So let's back up and take a look at just a generic quadratic equation and what has gone into it. Okay? So first of all, we could say that there is a point which is either the highest or lowest. Here, there's a lowest point. It's called the vertex. Here, the vertex was at 0, 0, right? It's the turning point. And it's a minimum. It's the lowest point here. Okay? The overall shape of the graph, we said, was a parabola, right? A U-shaped curve. And we write the equation in standard form, ax squared plus bx plus c. A does not equal 0. I'm missing that. A cannot equal 0. If a equaled 0, it would wipe out our squared x, our squared input. And that's what creates a quadratic equation, is squaring an input. So once we have a quadratic equation with some value in a other than 0, we will end up with a parabola, a U-shaped curve. There's this imaginary line that we could draw right through the vertex, right? And then we could fold this parabola right on that line, and every point on the right would have a reflected point on the left. So we call this parabola symmetrical, right? And so every point on the left has a corresponding point equidistant from this imaginary line on the right. And so we call this the axis of symmetry. Let's see if I can bring that up here. Axis of symmetry. Symmetry. It's symmetrical. Kind of like our bodies are bilaterally symmetrical. We could draw lines straight down and we have a leg on each side, we have arms on each side, we have eyes on each side, half a nose on each side. So we're kind of that way too. Okay, so there we go. Let's go try it again. Let's go try graphing when the a value is less than 0, which means the a value is negative. So look here, we have a negative 1/2 in front of x squared. What will that do to the graph? Okay, so go ahead and pause, see what you can find out, come back and check. So you plugged in 0. When you do, 0 squared is 0 times 1/2, 0. Plugged in 1, 1 squared, 1 times a negative 1/2 is negative 1/2. Plugged in 2, 2 squared is 4, right? 4 times negative 1/2 is negative 2. Plug in a negative 1 and we end up with negative 1 squared is positive 1, so we get negative 1/2 again. And we plug in negative 2, and when it's squared it becomes 4, and 4 times negative 1/2 is negative 2. Okay, so when you graph these, you probably saw that we have 1 and negative 1/2, 2 and negative 2. That we now have a u that is not right side up. It's upside down. So what about this equation flips a parabola upside down? And if you said the negative, you are right. It's that negative. Now the 1/2 did something too. The 1/2, did it make this, the u steeper or more shallow, flatter? And it made the u more flat, right? So we call that a vertical shrink. It's falling away from the y-axis. The 2 here causes a vertical stretch. It stretches this toward the y-axis, okay? And it's positive, so we have a right side up u. This a is negative, so we have an upside down u, okay? So what we'll do is we will graph quadratic equations and compare them to the parent quadratic equation. The most basic quadratic equation is when the a value here is 1. Y equals x squared. So we'll graph these other equations and say, how do they look different from the parent equation? So let's start with the parent equation. Go ahead, pause the video and graph it. Okay, so hopefully you have graphed the parent quadratic equation by substituting these basic values in, and here it is, right? So now we're going to graph y equals x squared plus 1. The only difference between this and the parent is adding 1. So in this C position, we've added 1. What will that do to the parent equation? How will that change it? So when we plug in 0 here, 0 squared is 0 plus 1, 1. Let's plug in 1. 1 squared is plus 1 is, good. We plug in 2. 2 squared plus 1, good, 5. We plug in negative 1. Negative 1 squared plus 1, 2, good. And then plug in negative 2, and what do you get? Very good. So when we go and graph these points, we have 0, 1, right? We have 1, 2. We have 2, 5. Negative 1, 2. Negative 2, 5. Okay, so when we draw the parabola, what is the change from the parent function? Well, they look alike, but the new function has moved up. We call this a slide. So in math terms, do you remember what a slide is? It's a vertical translation. Now, a slide could go horizontal. We could go left or right as well, but in this case, the parabola has just moved up. There doesn't seem to be a steeper parabola or a flatter one. It's simply moved up. So that's a vertical translation. Good job. Okay, so let's do this with a few more quadratic equations and compare them to the parent function. So please pause, draw your parent function, and try y equals negative 4x squared, and come back and check. Okay, our parent function is there, and if you have tried this new equation, y equals negative 4x squared, you have found when you plug in 1 squared times negative 4 is negative 4. 2 squared is 4 times negative 4 is negative 16, right? Negative 1 squared is 1 times negative 4 and negative 16. So this second function, that y equals negative 4x squared, we could plot 0, 0, 1, negative 4. 2 would be way down, somewhere down there, right? Negative 16. Negative 2 is also way down there. So this parabola is looking like that. So we could say that this parabola is upside down. So this is a reflection in the x-axis. It's reflecting over the x-axis, and that's because of that negative over here, right? The 4, that a of 4, has caused a vertical what? Good, stretch. So those are the two transformations that we have for that equation. So let's try this equation. 1/3 x squared. Okay, when we plug in 0, we get 0. When we plug in 1, we get 1/3. When we plug in 2 squared is 4, 4 thirds, 4 thirds, 1 1/3. And then we get those same values when we plug in the negatives, because the negative is canceled by the square root. So when we graph this, we end up with 0, 0, 1 1/3, 2 is 1 1/3. Negative 1 1/3, 2 is negative, or I'm sorry, positive 1 1/3. So this equation, y equals 1/3 x squared, is not a reflection. It's going the same direction as the parent, but it is looking flatter, right? So we would call this a vertical, what is it called? When it goes flatter away from the y? Vertical shrink by a factor of 1/3, right? Which, by the way, we could have set up here the vertical stretch for this equation is the factor of 4, right? The reflection is the negative that we saw with 4. Okay, we have one more to do. Pause the video and try it. Come back and look at what we have. Okay, so there's the values we get when we plug in these numbers for this equation. I'm using purple to graph this on the same graph. So we plug in 0 and we get negative 2. We plug in 1 and we get negative 1. We plug in 2 and we get 2. This is a lot for one graph, isn't it? We plug in negative 2 and we get 2. So I hope you can see this. Okay, so how is this different than the parent? Well, the vertex has slid down. See that? Sliding. We call that a vertical translation. And it's gone, that's an L, it's gone down 2, hasn't it? Down 2. And so that's what we see here, right? And otherwise, it's pretty much the same as the parent equation. Very good. You'll have to pause and take this down, but we've learned today that the a value can, if it's positive, the parabola opens up. If it's negative, the parabola opens down, right? The c value can translate the parabola up or down. So that's the effect of a and c. Also, the a term can, if it's negative, reflect, turn it Well, that's what it says here. I'm sorry. We already got that. Okay, so have fun when you're graphing these quadratics. Good job.